The solution of the system of the linear equation are the intersection points of the graph of the equation. That means the common point for both of the graph. So when two linear equations are graphed, one of the three possible outcomes will occur. So we're going to look at the three possible outcomes and the three systems of solution. The first system is called consistent of system. It's where you have two graphs cross each other as the common point here. So this system is called consistent because we have at least one solution. Now you see the two equations or two lines are different, having one common point. So we call this two equations here are independent equations. Now there's another possibility of our outcome will be the two lines are parallel. When two lines are parallel, the two lines are different. So we have no common point. So we have no solution. So when the system have no solution, we call the system is inconsistent because I have no solution. Now the two lines are different, so therefore we call them independent equations. There are another system that we have, another type we have, this is when we graph a two lines, they match, they're identical. The two lines are the same identical line. In this case here, we call the system is consistent, like this case, because we have at least one solution. Because the two lines lie on the top of each other, identical, so we have infinite common point between the two lines. So because they are the same, we call them dependent equations. I missed the S there. So these are three possible outcomes when we graph the line. Now, to solve the system by graphing, there are three steps that you need to remember. Step 1, we graph two equations on the same set of axes. Step 2, if the lines intersect, then we have to find the coordinate of the intersection point. It should be the order pair. The solution is the order pair, have x and y. And third, we go back and check the solution in both of the original equations, make sure everything is look good. These are three steps by solving the system of linear equation into variables by graphing. Now, let us look at the example solving the system by graphing. Solution. First step, we're going to graph this two line. So I'm going to change this into to a graph. So let's call this line here line 1, and let's call this line 2. Okay. So I'm going to graph line 1 by using blue ink. So I see that for line 1, the slope here is 2 over 1, and the y-intercept, which is b, equal to 1. So right here is the y-intercept. So the slope means changing in y over changing in x. This means changing in y is changing in x. So go up by 2, go to the right by 1. Okay. You can also rewrite the slope at -2 over -1. It's the same value because -2 over -1 is a positive 2. Then you start from the y-intercept. -2 means you go down by the y and go to the left by. Okay. If you want to be more precise, you can continue find now point from here, go up to right 1. So I got now a point here. Then you just draw a line. So I just connect the point together, extend it a little bit up like that. And then now let's graph line 2. Let's graph line 2 by using red. Okay. So for line 2, which is y equal to -x plus 4. So the slope here is -1, and the y-intercept, which is 0, 4, so b is 4, -1, let me say minus there. -1 can be write as -1 over 1, or we can write as 1 over -1. It's the same. So now to graph line number 2, locate the y-intercept, which is 1, 1, 2, 3, 4 right here. So I'm using this slope right here. This one here is a go -1, meaning you go down by 1, and the positive one here means you go to the right by 1. So right here I have this point. Then if you like to continue to do one more point, you can go down 1, right 1. If you use this one here, you have to go up 1 to the left 1, so it'll be right there. This one here, because remember this mean y, and this is mean changing in x. So positive mean up. This one here mean go to the left. So I go from my y-intercept, I go up, left 1. So now I just connect the point. So I just connect the two other points together for line 2. And you see that the two lines intersects at this point. So at this point here, if you read it would be x is 1, y is 3. So that is the point that's common between the two lines. So let's put the green here. That's the common point between the two lines. That's step 2. After we graph, we locate the point that they intersect each other between the two lines. And then step 3, we're going to check the solution. It looks like this is solution, the common point between the two lines, but we have to always check to make sure. Because if your graph is wrong and you graph something wrong and it come out a different number, you don't know until you check. Okay, so it's important that you check. So we claim that y is 3 equal to 2 times x is 1 minus 1. So the question mark right here, I have 3 equal to 2 times 1 is 2 plus 1. And then you have 3 over here and 3 over there. 3 is equal to 3, so it's true statement. I'm going to do the same thing, check for equation number 2. So I put 3 for y equal to minus x is 1 plus 4. So I'm checking, so I put a question mark here. So 3 equal to minus 1 plus 4 is 3. So you have 3 equal to 3. So it is a true statement. That means this is your answer. Alright, so that is your answer. Now let's say if you graph two lines and you find the intersection between the 2 points and you check it and it's not true, that means your line wasn't accurate. So it's very important that you always check your answer when you solve the system of equation by graph.